Hi guys, today we're going to cover lesson 13-1. This is our first lesson under the topic of inequalities. We have a lot of things in life and in math that are equal, but we also sometimes have things that are not equal, and those things could be sometimes less than, sometimes greater than, and so we're going to deal with those kind of ideas today.
An inequality is a mathematical sentence that uses the less than or equal to, greater than or equal to, or not equal to symbol to compare the values of two expressions. You will learn to recognize word phrases that indicate an inequality. For example, is fewer than indicates the less than symbol.
Okay, I'm just going to give you a moment to make sure that you copy each symbol that goes with each word phrase. It's going to be important that you learn how to recognize these symbols. Like when you see the first symbol here in red, you should know that that means less than and not greater than. A lot of times we can get the two confused.
A solution of an inequality is any value of the variable that makes the inequality true. You can use a number line graph to indicate all of the solutions of an inequality with one variable. The solutions of the inequality x less than 3 are all numbers less than 3. The open dot shows that 3 is not a solution.
Okay, when we have inequalities and we're talking about the numbers that are less than 3. We have lots of numbers that are less than 3. So we do not just have one answer or solution. We have a solution set. We have lots of answers. Specifically, we have an infinite number of answers. There's an infinite number of answers that are numbers that are less than 3 because we can go negative however much we want. Negative 20, negative 234, negative 5,380. Those are all still going to be less than 3. When we have an inequality, we like to graph it so we can get a visual sense of the solution and what it means. This particular graph is showing us any number less than 3. The open dot shows that 3 is not a solution. So when we say something is less than 3, we can't use the number 3 itself. We can only use all the numbers that are less than 3. So if you could go ahead and make this graph onto your note sheet, that would be good. Sometimes when you're just using a pencil, because like obviously on this screen, the blue line really stands out. But when you're just using a pencil and you're graphing, sometimes when you draw it, you can make your open dot and then you sketch out your line. It may not show up very well, so I know sometimes I will even kind of color it in like a little squiggly dot just so that it really shows up as you are looking at your paper.
The graph shows that 2 and 9/10 and 0 are both solutions of x less than 3 because they fall on the shaded portion of the number line. In fact, x less than 3 has an infinite number of solutions. The solutions of the inequality x less than or equal to 3 are all numbers less than 3 or equal to 3, including 3. The closed dot shows that 3 is a solution.
Okay, so on this one, whenever you make your graph, you're going to copy the same shading and you're going to close in the dot, because when we say that x less than 3, or I'm sorry, when we say x is less than or equal to 3, we do mean any number that's less than 3 and also 3 itself. And so by coloring that in, we're shading in the exact spot of 3 as well.
Welcome to One of These Things is Not Like the Others. Let's play. 3 of the statements have the same solution. Cross out the one statement that has a different solution.
Okay, so this is really getting us to think about the words themselves and to figure out what kind of mathematical symbol that's indicating. Whenever we read through these, I'm going to kind of get you started on this first one, but then if you could pause the video and kind of test them out yourself, and then if you'll continue listening, you can kind of test yourself to see if you're understanding this. Okay, so on the first one, it says a number n, so we don't know exactly what number we're talking about, but we know it's no more than 25. So we have to kind of think, is that talking about numbers that are less than 25 or greater than 25? And we also want to consider, could it be okay to have exactly 25? Well, whenever we read this no more than 25, like if I think, hey, okay, today I can have no more than 25 kids in my class, then I've got to think that that means that I can have less than 25 kids, but I can also have exactly 25 kids. No more than just means that it can't be greater than 25. So the mathematical inequality that we would write for this will be n is less than or equal to 25. Okay, 25 is the biggest amount that we can have. This number that we're talking about, this unknown number, has to be less than 25, and it could also be equal to 25. Okay, so go ahead and pause the video and see if you can figure out what the rest mean. Okay, hopefully you tried them out on your own. On this one, if we have a number n is at most 25. When we say at most, we do mean that it can be up to exactly 25, but it just can't go more than that. So this is also saying the same thing as the first one. Okay, you will work fewer than 25 hours this week. When we hear the word fewer than, we are talking about less, not more. And when it says fewer than 25, that means it can't even be 25. It has to remain less than 25. So we would not include that or equal to symbol. Okay, this one, a legal speed to travel in a 25-mile-per-hour zone. Well, we know that if you're having a speed limit, you have to travel that speed or less. So this would be like the first two. So we can cross out this third one. It is not like the other three. All right, let's try another set.
All right, let's see what challenge is behind curtain 2. 3 of the statements have the same solution. Cross out the one statement that has a different solution.
Okay, so at this point, pause the video again and see if you can do each one on your own. Then play the video when you're ready to hear my answers. Okay, so on the first one, the cost for internet starts at $30 per month. That's the starting amount. So it means it's going to keep going from there. That means that we can have numbers that are greater than 30. The cost for internet starts at $30 per month. We don't really have to use a certain variable. We could stick with n like we had before, or maybe you want to use c for cost. But our cost can be $30. That's a starting price. It can be exactly $30, or it can keep going to be more. So the cost is greater than or equal to 30. All right, on this one, you traveled more than 30 miles yesterday. It doesn't say you traveled 30 miles. It doesn't say you traveled less than 30 miles. It says you traveled more than 30 miles. So your travel was greater than 30. In this picture, we see a filled in dot. That does mean that 30 is a possible solution. Like we are talking about exactly 30, and we can see it's shaded as more than 30. So this would be that our value is greater than or equal to 30. You'll kind of notice something as we work on inequalities, as we write them and graph them. If we write an inequality where the variable is on the left, and that's important, then the arrow of the inequality sign will point in the same direction as the arrow on the number line. Just something to notice, but it is important where your variable is at. If your variable is on the right, it's all backwards. All right, the last one says a number is at least 30. at least means that it can be 30 or it'll be more. So this one, again, will be greater than or equal to 30. So that means that the second one is crossed out. All right. This one, write an inequality to represent the following statement. You drank less than 2.5 cups of water today. Okay, so you've got to be thinking, is it talking about numbers that are less than 2.5 or numbers that are greater than 2.5? And we also want to think, what about 2.5 exactly? Like, is that okay? It's saying you drank less than 2.5 cups of water today. So it's not saying you drank 2.5, and it's not saying you drank more than 2.5. It's saying you only drank less than 2.5. Maybe D for how much we drank is less than 2.5. Keep in mind that we have a variety of solutions. Just because you drank less than 2.5 cups of water doesn't tell us exactly how much you drank. You could have drank 1 cup of water. You could have drank 2 cups of water. You could have drank just half of a cup of water. Another thing to kind of keep in mind with this question is whenever we start putting a context on the problem, like the idea of drinking water, sometimes it doesn't make sense for all of the solutions. I mean, think about it. -1 is less than 2.5, but you would never drink -1 cups of water. So sometimes we only really think about the positive answers in a certain situation. It really depends on what we're talking about. We are going to solve inequalities just like we solved equations, where we want to find the value of a variable. We know that with an inequality, there's going to be more than one value of a variable that will work for our inequality.
The addition property of inequality states that if you add the same number to each side of an inequality, the relationship between the two sides does not change. If A is less than B, then A plus C is less than B plus C for all numbers A, B, and C. For example, let A equal 3, B equal 7, and C equal 2. A number line can help show these relationships. 3 is less than 7. If you add 2 to 3, you get 5. If you add 2 to 7, you get 9. 5 is less than 9. Similarly, if A is greater than B, then A plus C is greater than B plus C for all numbers A, B, and C. The addition property of inequality is also true for less than or equal to and greater than or equal to.
So just like with equations, we were able to add a number as long as we added it to both sides of the equation and it still remained equal. Same thing with inequalities. We're allowed to add a value to both sides of the inequality and it will still remain that same inequality. Even though we added 2 to 3, as long as we also added 2 to 7, we can rest assured that our answer will still be less than this second answer.
The subtraction property of inequality states that if you subtract the same number from each side of an inequality, the relationship between the two sides does not change. If A is less than B, then A minus C is less than B minus C for all numbers A, B, and C. For example, let A equal 6, B equal 10, and C equal 9. A number line can help show these relationships. 6 is less than 10. If you subtract 9 from 6, you get -3. If you subtract 9 from 10, you get 1. -3 is less than 1. Similarly, if A is greater than B, then A minus C is greater than B minus C for all numbers, A, B, and C. The subtraction property of inequality is also true for less than or equal to and greater than or